Hi students, welcome to the online discussion of Matrices and Determinants part 2. In this video, we will be discussing about the nature of equations and how to solve them and types of that questions. And along with that, some properties of determinants will be discussed which will be useful for solving some of the questions based on this topic. Okay. So let's discuss the theory first. Okay. This involves two types of equations. First one is system of equations, non-homogeneous equations and homogeneous equations. At first we will be discussing the nature of solutions of non-homogeneous equations. Okay. See, let's take the three equations as a1x plus b1y plus c1z is equal to d1, a2x plus b2y plus c2z is equal to d2, and a3x plus b3y plus c3z is equal to d3. Okay, three equations are there. And what we have to do is normally form the determinants of four determinants mainly. First one is the coefficient determinant, that is a1, that is the coefficients of corresponding x, y and z variables respectively for the three equations, that is a1, b1, c1, a2, b2, c2, a3, b3, c3. Okay, and four determinants are to be placed, that is first can be taken as delta, delta 1, delta 2 and delta 3. And for delta 1, just remove the first column from delta and attach the corresponding constants of the each equations, that is d1, d2, d3. That is, detach this first column and attach d1, d2, d3 to obtain delta 1. Okay. And for delta 2, accordingly, second column from delta should be removed, and instead of second column, just substitute this d1, d2, d3 and same for d3. Okay. See, to find x, y and z, we need to use this formula only. X is equal to delta 1 by delta, y is equal to delta 2 by delta, and z is equal to delta 3 by delta. Asked to find the values of x, y and z. Okay, normally the questions will be based like this. To find the nature of solutions, the equations will have infinite solutions. You need to find alpha, beta relation between, like that sorts of questions will be there. Okay, this only I think 2 or 3 questions are asked in previous 2 or 3 years. Okay, so let's focus on the main thing first. Okay, first we need to find the value of the main determinant, that is the coefficient determinant. Okay, and that we need to check first, and either it will be 0 or non-zero. Okay, if it is not equal to 0, then the equation will be consistent. Consistent means the equation will have a solution and has a unique solution, and the corresponding values will be x is equal to delta 1 by delta, y is equal to delta 2 by delta, and z is equal to what? Delta 3 by delta. It will be like this. Okay, and in most the cases the determinant will be 0. Okay, the coefficient of determinant will be 0, and if it is 0, there are two additional cases, sub cases will be there. That is, we need to find the values of delta 1, delta 2 and delta 3. Okay, in most cases either one of the values will be sufficient. Okay, and if all of delta 1, delta 2, delta 3 is 0, then also the equation is what? Consistent, but the equation will have infinite number of solutions. I hope it's clear. And if at least one of delta 1, delta 2, delta 3 is not 0, then the equation is inconsistent. Inconsistent means the equations will have no solutions. Okay, so that will be the case. I hope it's clear. Okay, mostly the questions will be based on this. The determinant is equal to 0 and all of the subdeterminants is equal to 0. Okay, that is infinite number of solutions will be the questions. The question will be asked on this region. Okay, majority of the questions. Okay, I hope it's clear. Let's move to the next one. Okay, that's for two variables. Before that, see, for homogeneous equations. For homogeneous equations, see, if the equations are like this, a1x plus b1y plus c1z is equal to 0, a2x plus b2y plus c2z is equal to 0, a3x plus b3y plus c3z is equal to 0. Okay, then also you need to form the parent determinant, that is a1 b1 c1, a2 b2 c2, a3 b3 c3. Okay, and all of these values will be 0. Delta 1 which is equal to delta 2 which is equal to delta 3 which is equal to 0. Why? Because for finding delta 1, what we need to do is detach the first column from here and attach 0, 0, 0 here. Okay, we know that from the properties of determinants, if all the elements of a row or all the elements of a column becomes 0, then the net value of the determinant will be equal to 0. Okay, so this will be 0 for all the cases. Okay, we don't have to bother much about that. But here we need to study two cases. See, whatever the case, the system of equation will be consistent for homogeneous equations. Okay. That is, we need to find the determinant of the coefficient matrices. See, either it will be not equal to 0 or the determinant will be equal to 0. See, if it is equal to 0, then the equation will have infinite number of solutions. Okay, and if it is not equal to 0, then the equation will have a unique solution. And the solution will be x is equal to y is equal to z is equal to 0. It is also called a trivial solution. Okay, compared to these two, this is more important. Okay, the weightage is more in this region. Okay, I hope it's clear. See, for homogeneous, you need to find the parent determinant, and if the value of the determinant is 0, then the system of equation will have infinite number of solutions, and if it is not equal to 0, then the system of equation will have a trivial solution. And what is that solution? X is equal to y is equal to z is equal to 0. Okay, and that's all for Cramer's rule. Okay, that is what Cramer's rule is. And now we are going to discuss about the properties of determinant, which will be useful for solving some of the questions. Okay. Okay, before that, involving two variables. Okay, see, for two variables, I think it's not necessary to discuss, and it is not necessary to go through Cramer's rule and that sort of things, because you already studied this in 10th standard. Okay, for two variables, you know that if you compare the corresponding coefficients, if it is a1 by a2 which is equal to b1 by b2, and if it is equal to c1 by c2, then the two equations will represent a coincident line, and then therefore infinite number of solutions will be consistent in this case. Okay, and if a1 by a2 equal to b1 by b2 which is not equal to c1 by c2, and you know that they are parallel lines, therefore no solution. And if a1 by a2 not equal to b1 by b2, then they are intersecting lines, therefore only one solution. Okay, we don't have to go through Cramer's rule for that. Okay, now properties of determinants. Okay, very important one. Okay, three properties will be discussed here. So many properties are here. I have pinpointed three properties which is most commonly used for solving the questions relating the equations. Okay, so first one, all zero property. See, if all the elements of a row or column are 0, then the value of the determinant will be 0. It is like, okay, we can discuss this in the next page. That is, if it is either 0, 0, 0 or 0, 0, 0, then the value of the determinant is what? 0. Next property, actually the second and third properties are the most commonly used one. If all the elements of a row or column are proportional or identical to the elements of some other row, then the value of the determinant is 0. It's a very useful property. That is, if a determinant is placed like this, 1, 2, 3, 7, 10, 11, 1, 2, 3, then you don't have to solve this. Just put it is equal to 0. Why? Because the corresponding elements in the first column and second column are identical. Okay. See, even though they are not identical, there is one more property. That is 1, 2, 3, 7, 10, 11, 3, 6, 9. The value of this determinant is also equal to 0. Why? Because the third elements in the third column is a scalar multiple of the elements in the first column. Then also the value of the determinant will be 0. Same goes for rows also. Okay, I am not discussing in CD here. Same goes for the elements in the row also. That is, if 1, 2, 3, 7, 8, 9, 1, 2, 3. This value, the value of this will also be equal to 0. Okay, so those are the two properties. And the next one. Okay, the most useful one among this. That is property of invariance. That is determinant of A1, B1, C1, A2, B2, C2, A3, B3, C3. That is determinant of a matrix. Okay, which is equal to A1 plus alpha B1 plus beta C1, B1 C1, and A2 plus alpha B2 plus beta C2, B2 C2, like that. Okay, so what we need to understand here is the value of this determinant won't change if you perform elementary operations. Okay, if you perform a legitimate elementary operation. Legitimate means you have to put it like this. If you are planning to change R1, you have to put it like this: R1 plus R2 plus R3, or various elementary operations are there. R1 changes to R1 minus R2 like that. But never use this one. R1 changes to R1 minus R2 is okay. But never use this one. R1 changes to R2 minus R1. If you are planning to change any row or column, just place them as first and their coefficient should be 1. Okay, never use this one. R1 changes to 2R1 plus R2. Okay, it's not correct. Okay, if you are planning to change any row, just keep it like this here. Okay, I hope it's clear. I will go through an example to make it easy. Next one. So, if you have to find the value of a determinant like 1, 4, 5, 3, 8, 1. Okay, and here we can put 2, 6 and 3. What is the value of the determinant? Without expanding or without going through the operations of determinant, could you identify the value of this determinant? It's 0. Why? Because if you present it like this, R1 changes to R1 plus R3, then this determinant becomes 4, 12, 6. The first row becomes. And what about the second row? 2, 6, 3. Right? You don't have to write this one. The value will be 0. Why? Because the elements in the first row is a scalar multiple of the elements in the second row, right? If you multiply 2 here, you will get 4, 12 and 6, which is identical to row 1. Therefore, the determinant will be 0. Okay. We have to, we can keep this property handy to do a lot more questions with minimal steps. Okay. I hope it's clear. Let's move to the questions. Okay. Just keep this handy. Okay. Next one. Okay. The very first question. If the system of linear equations, okay, it's non-homogeneous, has infinitely many solutions, then you have to find the value of 12 alpha plus 3 beta. And how will you find the value of 12 alpha plus 3 beta? See, if the system of equations having infinite number of solutions, then we know that delta is equal to, delta 1 is equal to, delta 2 is equal to, delta 3 is equal to 0. Okay, and using this property, we need to find alpha and beta. Okay, so let's form delta first. So what is delta? Delta is equal to 1 minus 2, 1, 2 alpha 3, 3 minus 1 beta. Okay, equate this to 0, but there is a small problem. If you equate it, you will get an equation. Okay, obviously you will get an equation which is equal to 0, but in that equation there are two unknowns, alpha and beta. So it's not easy to solve that equation. Okay, so instead of using delta, just use delta 1 and delta 2. Okay, by using delta 1 and delta 2, the alpha and beta will get separated. Okay, and you will get a unique equation for alpha and another equation for beta. Therefore, it can easily be solvable. Okay, I hope you got the idea. Okay, let's do this. So I am eliminating this. Okay, we can take delta 2. Delta 2 is equal, only then the alpha and beta will get separated. Delta 2 is equal to 1, 2, 3 minus 4, 5, 3, 1, 3 beta. Okay, and equate it to 0. Okay, 1, 2, 3 minus 4, 5, 3 and 1, 3 beta. You will get beta first. That is, if we solve it, it will be like 1 into 5 beta minus 9. 5 beta minus 9 and plus 4. Minus 4 becomes plus 4 and 2 beta minus 9. That is 2 beta minus 9 plus 1 into 6 minus 15. 6 minus 15 is equal to 0. That is 5 beta minus 9 and this becomes plus 8 beta minus 36 minus 9 is equal to 0. Okay, and this becomes 5 beta plus 8 beta, that is what? 13 beta, and 13 beta which is equal to 54. Okay, just don't find beta, we need to find 13 beta, the answer in terms of 13 beta. You already got 13 beta. What is 13 beta? 54. And we need to find alpha also, and for that we can use delta 3. That is, we know that delta 3 is equal to 0. And what is delta 3 actually? Delta 3 is 1, 2, 3 minus 2 alpha minus 1 and minus 4, 5, 3. Okay, this is what delta 3 is. And this should be equal to 0. Okay. And if we equate it, it will be like, we can do it in the next slide. Okay. That is 1 into 3 alpha plus 5. That is 1 into 3 alpha plus 5. Okay. Plus 2 into 6 minus 15. Plus 2 into 6 minus 15. Okay. And minus 4 into minus 2 alpha minus 3 alpha. Minus 2 minus 3 alpha, right? Minus 2 minus 3 alpha, which is equal to 0. Okay, just open the bracket, you will get the value of alpha. That is 3 alpha plus 5. This is minus 9 into 2 is minus 18. And this is plus 8 plus 12 is equal to 0. 12 alpha is equal to 0. And 3 alpha plus 12 alpha is 15 alpha. 15 alpha, this is 13, which is equal to 5. That is alpha is equal to 1 by 3. Okay. You need to find 12 alpha plus 13 beta, right? And what was the value of 13 beta? That is equal to 54. We know that alpha is equal to 1 by 3. That is 3 alpha is equal to 1. Therefore, 12 alpha means you need to multiply both sides with 4. That is 12 alpha is equal to 4. It will be 4. The answer will be 58. Okay. Hope it's clear. Okay. In this way, the questions will be asked. Okay. They will already say the nature of, they will already explain the nature of equations like that. It is trivial, non-trivial, infinite solutions, no solution at all. And then they will ask you to find alpha and beta or any relation between alpha and beta like that. Okay. Sometimes they will integrate another chapter into this. Okay. The questions from determinants and plane is there. We will discuss that questions, and 2D is there. Probability is also there. Okay. They have mixed up all of these chapters. Okay. And will ask questions. Okay. And the next one. Okay. If the system of equations x, y, a, 2, 5, 2z, that is x plus y plus az is equal to b, 2x plus 5y plus 2z is equal to 6, x plus 2y plus 3z is equal to 3, has infinitely many solutions, then the value of 2a plus 3b. Similar to the previous question. Okay, if you want, you can do it by hitting the pause button. Just, okay, do it by yourself. It will be better. Okay. See, you know how to solve this, right? We had detailed this in the last question. Okay, you know how to solve this in the conventional method. Okay, in this problem, I am going to explain a shortcut for solving this without using determinant. Okay, you are hearing it for the first time here. Okay. Without using determinant, we are going to solve this. How? Let's equate it first. Okay, determinant is equal to 0, right? That is 1, 1a, 2, 5, 2, 1, 2, 3. This should be equal to 0. Without expanding, that is by using the properties of determinants, we can solve this and you will easily get the value of a. And how will you solve this? Any idea? Yes. See, if you add 2 plus 1, what will you get? 3. 5 plus 1, what will you get? 6. See, if you add, that is, if you attempt it like this, R1 changes to R1 plus R2. And this becomes what? 3, 6 and what? A plus 2. 2, 5, 2, 1, 2, 3. We already know that it is equal to 0. We don't have to find the value of the determinant. We already know that that is equal to 0. See, using the properties of determinant, as I told you before, if all the elements of a row, okay, is equal to the scalar multiple of all the elements of any other row, then the value of the determinant is 0, right? See, what is the element in the first row? 3, 6, a plus 2. Let's take the first two elements, that is 3 and 6. Are they equal to the scalar multiple of elements in any other row? Yes, that is 1 into 3 is 3, 2 into 3 is 6. Okay, so 3, 6, a plus 2. Okay, if you multiply here with 3, that is 3, 6, 9. It should be same, right? 3 and 3 are same, 6 and 6 are same. Therefore, these two should be same. Okay, I hope you are getting the idea. Therefore, we know that a plus 2 is equal to 9. Therefore, a is equal to what? 7. Now, you got the value of a. See, if you go through the conventional method of solving the determinants, then also you will get the value of a as 7. Okay, this is merely the shortcut. Next one, and you know, and we need to find the value of b also. It's very easy, like this. We will get the value of b. That is 1, 1, b, 2, 5, 2, 1, 2, 3. Just add these two. Okay, whatever the method we are used here, you can use the same method here to find the value of b. Okay, if you add this and this, it will be 3, 6, b plus 2. Just don't mind about this row. Okay, 1, 2, 3. See, we know that this is the elements in this row is the scalar multiple of elements in this row, right? Therefore, this becomes, it should be equal to 3, 6 and 9. Okay. Sorry, it's b plus 6. Okay. B plus 6. Okay. Therefore, we know that b plus 6 is equal to 9. Okay. 3, 6, 9. That is 3 is equal to 3, 6 is equal to 6. Therefore, b plus 6 is equal to 9. Therefore, b is equal to what? 3. So, we got the value of a and b as a is equal to 7 and b is equal to 3. Substituting here, you will get 2a will be 14 and 3 into 3 is 9. That is 14 times 9 is what? 23. That is option A is the correct answer. Okay, I hope you got it. Okay, that's all. And the second one. Next one. If the system of equations x plus 4y minus z is equal to lambda, 7x plus 9y plus mu z is equal to minus 3, 5x plus y plus 2z is equal to minus 1 has infinitely many solutions, similar question, then 2 mu plus 3 lambda is equal to c. This question can also be solved using the method we just mentioned in the last question. Okay, using the properties of determinants. Okay, it won't take much time for that. Okay, that is 1, 4 minus 1, 7, 9 mu, 5, 1, 2. Okay, this is equal to 0. Okay, could you point out the relation between the elements? Just hit the pause button and try to figure out the relation between the elements. What is the relation between the elements? It's very easy actually. Listen, just multiply here with 2. Okay, or just use it like this. R2 changes to R2 minus 2R1. So what happened? R2 means 7, 9 mu and 2R1 means 2, 8 and minus 2. Okay, if you subtract these two, you will get 1, 4 minus 1 as the first row. It won't change. Second row will change. That is 7 minus 2 is what? 5. 9 minus 8 is 1 and mu minus 2 is what? Mu plus 2. Okay, and 5, 1, 2. Okay, so what is the value of mu? It's very easy. See, these two rows are, the elements in row 2 and row 3 are identical, right? 5, 5, 1, 1. Therefore, these should be same. Then what should be the value of mu? 0. Only then it will be same, right? Okay, therefore, mu is equal to 0. You can use the same method to find the value of lambda. Okay, so it will be like 1, 4 lambda, 7, 9 minus 3, 5, 1 and minus 1. Okay. So after that, after equating these two like this, that is 7, 9 minus 3. 7, 9 minus 3, multiply this with 2. That is 2, 8, 2 lambda. That is, if you subtract this, it will be 5, 1 minus 3 minus 2 lambda, and it will be same as the last row, that is 5, 1 minus 1. Okay, both of them are same. Therefore, minus 3 minus 2 lambda is equal to minus 1. That is minus 2 lambda is equal to what? Is equal to 2. That is lambda is equal to minus 1. So, you got the value of mu as 0 and lambda is what? Minus 1. Very easy question. Therefore, if mu is 0, this part becomes 0, and if lambda is minus 1, 3 into minus 1 is what? Minus 3. That's all. Okay. So, should be. Hope you are getting the idea. Okay. Next one. Okay, another type. For the system of linear equations, alpha x plus y plus z is equal to 1, x plus alpha y plus z is equal to 1, x plus y plus alpha z is equal to beta, then which among the following statements are not correct? Okay. Okay. See, all the theories embedded in here, that is infinite solution, no solution, like that. Okay. We need to pinpoint which among these statements are incorrect. Okay. So, let's find the values first, and let's find the values of the parent determinant, that is delta. Delta is equal to alpha 1 1 and 1 alpha 1 and 1 1 alpha. Okay, I'm just opening this determinant. Okay, see, there is we know that by substituting alpha is equal to 1, this determinant becomes 0. But the problem here is, if you just imagine, if you open the determinant, there will be lambda cube, right? There will be a term with power 3. Okay. If there is a cubic equation, there is a possibility that it will have more than one root. Okay. Therefore, lambda is equal to 1 might not be the only root. There will be other values also. That's why I need to expand this. Okay. If they said that there is only one value, then it will be fine. Okay. Then if you open it, it will be like alpha into, this is alpha square minus 1 minus 1 into, this is alpha minus 1, alpha minus 1, and plus 1 into 1 minus alpha. Okay. Then see, if you open the bracket, it will be a cubic equation. Okay, and it will be, we have to go through some tedious steps to operate that. So there is one method which we can do it from here itself. Okay, if you filter it properly, it will reduce to a quadratic equation. And how will you do that? See, here we have alpha square minus 1, here we have alpha minus 1, and here we have 1 minus alpha. If you take a negative from here, it becomes alpha minus 1. So basically alpha minus 1 is common for these three terms. If you take it outside, then the inside term will be a quadratic equation. Okay, I hope it's clear. Therefore, alpha into alpha plus 1 into alpha minus 1 minus alpha minus 1 minus alpha minus 1. Take alpha minus 1 outside, and it will be alpha minus 1 into alpha plus 1 minus 1 minus 1. Okay, that is okay. That is, it will be alpha minus 1 into, this becomes alpha square plus alpha minus 2. That is, this becomes alpha square plus alpha minus 2. And you know how to factorize this, right? Alpha square plus alpha minus 2 can be written as alpha minus 1 into alpha plus 2 into alpha minus 1. Okay. Therefore, it can be written as alpha minus 1 whole square into alpha plus 2. So, this is the value of the parent determinant. Okay, I hope it's clear. Then, what about the value of the determinant 1? We need to find the value of determinant 1 also. That is, just replace alpha 1 1 with 1 1 beta. That is 1 1 beta. This will be 1 alpha 1, and this is 1 1 alpha. Okay, you can use the value of alpha as 1. Okay, that is 1 1 and 1. Okay, I'm just taking the value of, there is two values of alpha actually. If you are equating this to 0, alpha is equal to 1 and alpha is equal to minus 2. Okay, so if alpha is equal to 1, then what should be the value of beta? Beta is equal to 1. That is, if beta is equal to 1, then the R1, column 1 and column 2 becomes identical. Then this value of this determinant will be equal to 0. Okay, so this is one possibility. So, we need to go through the options first, okay, to verify which one of the following is incorrect. Okay, so before that, we need to conclude the things here. That is, D is equal to 0 for alpha is equal to 1 comma minus 2, and delta 3 is delta 3. This is delta 3. Sorry, delta 1. Delta 1 is equal to 0 for beta is equal to 1. Okay, these are our conclusions by solving this, and then we need to go through the options. Okay, the first option is it has infinitely many solutions if alpha is equal to 2 and beta is equal to minus 1. See, it's fortunately the first option itself is incorrect. And why is the first option incorrect? Could you tell me why is the first option incorrect? Because if alpha is equal to 2, then the value of the determinant is 0. And if beta is equal to minus 1, then the value of the determinant, whatever it is, determinant of 3 we can take, which is not equal to 0. Okay, then how will you see? Sorry, determinant of 1 is delta 1 not equal to 0. See, if alpha is equal to 2, then the value of the parent determinant is 0. And if beta is equal to minus 1, then the value of the delta 1, that is determinant 1, is equal to 0. Okay, so if delta is equal to 0, and we have studied in Cramer's rule that if delta is equal to 0 and if any one among the determinants, delta 1, delta 2, delta 3 is non-zero, then that is a case of inconsistency, that is inconsistent, that is the system of equation will have no solution at all. So basically this is incorrect. Okay, so you can expect these questions. This is a recent trend, these types of questions are asked in 2024 also. Okay. Okay, let's move to the next question. Okay, question which is very much like this. Okay, consider the system of linear equations. 3 equations are given: x, y, z, x 2y lambda square, x 3 lambda, x plus 3y plus lambda z is equal to mu, where lambda comma mu is element of R. Then which of the following statement is not correct? Okay, the system has infinite number of solutions that we can deal later, right? After sorting out this one. Okay, so I'm going to formulate delta 1 and delta 2. Okay, let's do this. Okay, we can start from here, right? That is delta, that is equal to 1, 1, 1, 1, 2 lambda square, right? And 1, 3 lambda, 1, 3 lambda. Okay, just equate this to 0. Okay, just equate this to 0. So how will you operate this? It's very easy. Without expanding the determinant also we can expand it. And how will you expand this how will you solve this without expanding the determinant and by using the properties of determinant? Any idea? If it is equal to 0, just look at the values in the first row, second row and third row. Okay, what is 1 plus 1? 2. What is 3 plus 1? 4. What is 2 times 2? 4. And what is 1 times 1? 2. That is the sum of R1 and R3 is equal to the scalar multiple of the second row, right? Therefore, they should be same. Otherwise, it won't be equal to 0. Therefore, I am equating like this. That is R1 changes to R1 plus R3. That is 2, 4 and lambda plus 1. Okay, 1, 3 lambda, 1, 2 lambda square. Okay, so if you look at this row is a scalar multiple of this row, right? If you multiply 2 here, you will get this row. Then this should be equal to 0, right? That is 2, 4 lambda plus 1, 2, 4, 2 lambda square. They should be same, right? That is, if you equate it, it will be like 2 lambda square is equal to lambda plus 1. That is 2 lambda square minus lambda minus 1 is equal to 0. It is a quadratic equation. And if you solve it, you will get two values. That is, the first value is lambda is equal to 1. The second value is, if you factorize it, it will be lambda is equal to minus 1 by 2. Okay, so two values of lambda is equal to 1 and lambda is equal to minus 1 by 2. Okay, then we can take delta 3. Okay, so what is delta 3? Delta 3 is 1, 1, 1, 1, 2, 3 and the corresponding constants are 5, 9 and mu, right? 5, 9, mu. Okay, you can use the same property which we have used here. Okay, that is R1 changes to R1 plus R2, that is this becomes 2, R1 changes to R1 plus R3. Okay, this becomes 2, 4 and mu plus 5. If you multiply this row with 2, this should be same, that is 2, 4, 18. That is mu plus 5 should be equal to what? Mu plus 5 should be equal to 18. then mu is equal to what? 13. Okay, so now you got the values of lambda and mu as well. Therefore, we can draw the conclusions here. That is, delta is equal to 0 if alpha is equal to 1 comma minus 1 by 2, and delta 3 is equal to 0 if what was the conclusion? If yes, mu is equal to 13. Okay, then let's go through the options. Okay, the system has infinite number of solutions if lambda is equal to 1 and mu is equal to 13. It's correct, right? See, if it's lambda, okay, it's not alpha, lambda. See, if lambda is equal to 1, then the value of the parent determinant is 0. And if mu is equal to 13, then lambda 3 is equal to 0. And which means that delta 1 is equal to delta 2 is equal to delta 3 is equal to delta is equal to 0. Okay, that is the system of infinite number of solutions if delta is equal to 1 and mu is equal to 13. That is all the determinant will become 0. Next one, system is inconsistent if lambda is equal to 1 and mu not equal to 13. It's correct actually. That is, if lambda is equal to 1, then delta is equal to 0, and mu not equal to 13, then delta 3 is not equal to 0. If delta 3 is not equal to 0, which means that the value of the parent determinant is 0 and the value of the at least any one among the values of delta 1, delta 2, delta 3, that is the value of the determinant of delta 1, delta 2, delta 3 is non-zero, then the set of equations will have no solution at all. Okay, I hope it is clear. And system is inconsistent if lambda not equal to 1 and mu is equal to 13. And what about that? System is inconsistent. System is consistent if lambda not equal to 1 and mu equal to 13. Is it correct? Let's check. If lambda not equal to 1, then also there is a possibility that lambda can take the value minus 1 by 2. Okay, what if lambda, okay, we can consider both the cases. If lambda not equal to 1, okay, then there is a chance that this won't be equal to 0. If this is not equal to 0, that is, let's take lambda not equal to 1. Okay, then there is a case that this delta is not equal to 0. Okay, by assuming that lambda is, see, for two values of lambda, this becomes 0. What are the values? For 1 and minus 1 by 2. Okay, that is a tricky part here. See, they have mentioned that lambda is not equal to 1 only. Okay, so I am considering two cases. The first case where lambda is not equal to 1. Lambda not equal to 1. And I am assuming that lambda is not equal to minus 1 by 2 also. By that, the value of the determinant is not equal to 0. And we know that if the value of the parent determinant is not equal to 0, then the system of equation is inconsistent. Okay. And let's take another case where lambda not equal to 1, but lambda is equal to minus 1 by 2. See, then also the value of the determinant is what? 0. If lambda is equal to minus 1 by 2 also, the value of the determinant is what? 0. See, that's the case. So this can be equal to 0 in the second case. And what if mu is equal to 13? In both the cases, if mu is equal to 13, the value of the other determinant is 0. Okay, then we can say that the system of equation is consistent. Okay, see, in one case this becomes 0 and in one case this is not equal to 0. If it is not equal to 0, we don't have to bother about the other determinants. They will be consistent. Okay, and if it is equal to 0, and we know that for the value of mu is equal to 13, the value of the other determinants are also equal to 0, then also the system of equations are consistent. Okay, see, we don't have to bother about whether they have a unique solution or infinite solution like that. Okay. And the next one, see, we don't have to go through this one. See, all the first three options are correct and this will be incorrect. Okay. And for the sake, we can check it. System has a unique solution if lambda not equal to 1 and mu not equal to 13. That is incorrect actually, because if lambda not equal to 1 and if lambda is equal to minus 1 by 2, then the value of the determinant becomes 0. And mu not equal to 13 means, which value we have taken for mu? Delta 3. Delta 3 is not equal to 0. Okay, so this is special case, but they have mentioned that lambda is not equal to 1 only. So lambda can take all other values other than 1. Okay, so if it is true, it should hold true for all the cases without any exception. But here, For the value of lambda is equal to minus 2, the value of the parent determinant is equal to 0. And if the value of the parent determinant is equal to 0 and if any one among the values of other determinant is not equal to 0, then the system of equations are inconsistent. Okay, it's a very good question. I hope you got the idea here. Okay, and see what happens for these types of questions is most of students will substitute lambda is equal to 1. If lambda is equal to 1, this column and this column will be identical. But the problem here is, if you look at here, you know that there is a lambda square. So if you solve this determinant, there is a possibility that you will get a quadratic equation. Okay, and if it is a quadratic equation, there is a higher probability that you'll have two roots. Okay, sometimes there will be one root if it is a perfect square. See, sometimes they will have another root. See, if you look at the options here, they haven't considered anything about, they haven't said anything about lambda is equal to minus 1 by 2. That is a tricky part of this question. They have only focused on the value of lambda is equal to 1. And that's most students make these types of questions incorrect. Okay, so be careful for this one. And the next one. Okay, slightly just go through the question. It's a very beautiful question and very beautifully crafted also. But if you look at it first glance, most of students will skip it. But there is no need of skipping this. It's a very beautiful question. Okay, so we know that alpha, beta, gamma is equal to 45. That's the first data given, and they have already mentioned that alpha, beta, and gamma is element of real numbers. And three homogeneous equations. Okay, three equations are given in a different manner. Okay, that is, this will be like alpha x plus 2x like that. Okay, so you have to represent in this way, that is, to perform the parent determinant, that is, it will be alpha 1, 2. That is, it will be like this, right? A1x, A2x, A3x. The coefficients of x will comes on a column. Okay, and what about the coefficients of y? 1, beta, 2, and what about the coefficients of z? 2, 3, gamma. Okay, and we know that delta 1 is equal to delta 2 is equal to delta 3 is equal to 0. That is, if you remove any column from here, you have to substitute a column where all the elements are 0. Obviously, that becomes 0. Okay, and they have already mentioned that x, the product of the three variables x, y, z, which is not equal to 0, then you need to find the value of 6 alpha plus 4 beta plus gamma. So what will you do here? Just try to do this question by yourself. Okay, it will be more good if you do it by yourself. Okay, hit the pause button and try to do it by yourself. And what will you do for these types of questions? See, majority of the people will think like this. If you open the determinant, no other data is given. Whether this equation is having infinite solutions. So they have mentioned that. They haven't mentioned like this, right? Okay, so what will you do in this case? X, y, z is not equal to 0. Yes, it is mentioned. X into y into z is not equal to 0. Okay, so in homogeneous equation, okay, forgot to mention that, forgot to look at that. For homogeneous equation, if delta is equal to 0, then the equation will have infinite number of solutions. And if delta not equal to 0, the equation will have only one solution, that is x is equal to y is equal to z is equal to 0. It is called a trivial solution. It's very important. See, using this data, just identify which among the cases preferred here. It's defined here, more precisely. So we can neglect this case. Why? See, if x is equal to y is equal to z is equal to 0, then the product is should be 0, right? But they have clearly mentioned that the product is not equal to 0. Therefore, we need to go for this one. That is, determinant is equal to 0 and the corresponding value of this determinant is equal to 0. See, the problem for most of students will think it like this. See, the value of this determinant is equal to 0, but we only get one equation in terms of alpha, beta and gamma. And how will you solve this without the information of any other data? No other data is given in the question. It is also an integer type question. No options are also not given. And how will you solve this? See, for these type of questions, we only have one option left. What is that? To expand the determinant. Okay, so let's try to expand the determinant. Okay, that is, starting from here, alpha into, this is beta gamma minus 6 minus 1 into gamma minus 6 plus 2 into 2 minus 2 beta. Okay, beta gamma minus 6 minus 1 into gamma minus 6 plus 2 into 2 minus 2 beta, and which is equal to 0. Okay, that is, if you open it will be alpha beta gamma minus 6 alpha minus gamma plus 6 plus 4 minus 4 beta, which is equal to 0. And what is the value of alpha beta gamma? Alpha beta gamma is 45. Okay, and what is 45 plus 4? 49. Okay, 49 minus 6 alpha minus gamma minus 4 beta is equal to 0. That's it. That's the solution. You got it? See, what is the value which you need to find here? 6 alpha plus 4 beta plus gamma. If you take everything to the right hand side, that will be 6 alpha plus 4 beta plus gamma. And what is the corresponding value? 49. Very easy question. Actually, it is more easy than the questions we did in this session. More easy than any of the question. Okay. I hope you got the idea here. See, if you are stuck like this and there is only one option left, like solving the determinant or some other case with respect to the problem, just give it a shot. Don't waste much time. Okay, if you get the answer, that's it. If you don't get the answer, just move to the next question. Don't waste your time for that. If you're practicing it, you can use numerous methods but for the exam, just go for the second question, next question. Okay. Hope it's clear. Next one. Mixed concept questions. That is, as I told you before, there are some questions which will be integrated along with determinants. I think in 2023, there is a question where they have connected sets and conics. Okay, and here also they have connected determinants with probability, determinants with sequences and series, determinants with 3-dimensional geometry, determinants with 2-dimensional geometry, determinants with quadratic equation, determinants with trigonometry functions, and those are the questions we are going to do just right now. And I think there is a question which we need to use the properties of determinants, sequence and series concept, and a small theory from straight lines to solve the question. Okay, it's easy. Okay, if you know all of this, then it's very easy. Okay, let's try to do this. Okay. First one, if alpha, beta element of R and this system of equation, I'm not going to read it, we need to solve it anyway, has infinitely many solutions, then alpha, you don't have to find alpha and beta, you need to find alpha and beta and form a root based on alpha and beta. See, for this you need to know determinants as well as quadratic equations. Okay. Okay, let's try to solve it. I'm going to write this in the next page. Okay, that is 1 minus 1 1, a part which we can solve here. That is 1 minus 1 1, 2 2 alpha, 3 minus 1 4. Okay, that should be equal to 0. Do we need to expand it or use any other techniques? Just tell me. Expanding or any other techniques? Tell. Any idea? We can expand it. Okay, that is 1 into, that is 8 plus alpha plus 1 into 8 minus 3 alpha. 8 minus 3 alpha plus 1 into minus 2 minus 6. Minus 2 minus 6, which is equal to 0. Okay, that is 8 plus alpha plus 8 minus 3 alpha minus 8 is equal to 0. Okay, this and this got cancelled. This becomes minus 2 alpha plus 8 is equal to 0, equal to minus 8. That is alpha is equal to what? 4. That's what, alpha is equal to 4. Now we got the value of alpha. Next one, you need to find the value of beta, right? For that also you need to expand. Okay, so what I'm going to do is, instead of this 1 alpha 4, I am substituting 5 8 beta. That should be equal to 0, right? That is, which we can do it in the next page. 1 minus 1 2 2, 1 minus 1 2 2, 3 minus 1 3 minus 1 and 5, 8 beta, right? 5, 8 beta. Okay, that is equal to 0. So this is 2 beta plus 8 plus 1 into 2 beta minus 24 plus 5 into minus 2 minus 6 is equal to 0. Minus 2 minus 6 is equal to 0. 2 beta, that is 4 beta. 8 minus 24, that is minus 16. Minus 8 minus 24 minus 16, this is what? Minus 8 minus 40, right? Minus 56, that is equal to 56, that is beta is equal to what? 14. So what was the value of alpha? Okay, alpha is equal to 4 and beta is equal to 8. So how will you form a quadratic equation if you know the roots? See, you know how to obtain the roots of a quadratic equation if the quadratic equation is given, right? Either using factorization method or splitting the middle term, or negative b plus or minus root b square minus 4ac by 2a the formula. Okay, you can use either one of the method effectively to get the value, to get the roots. So how will you form the quadratic equation if you know the roots? It's easy actually. If alpha and beta are the roots, if alpha and beta are the roots of a quadratic equation, then the quadratic equation will be x square minus alpha plus beta x plus alpha beta is equal to 0. Okay, very easy one. Okay, in 10th standard I think you have studied this. Therefore, what is alpha plus beta? 12. Beta is equal to 14, right? Sorry. The value of beta is 14. Okay, extremely sorry for that. Beta is equal to 14. Therefore, x square minus 18x. That is this one. This is the correct answer. Okay. Only one option with minus 18x. Okay, that is the correct answer. Okay, I hope it's clear. Let's go for the next one. Okay, interesting. The system of equations have infinitely many solutions. Then the system, this one and this one has the two equations, another two equations are given. See, a very good, very well crafted problem. System of three equations are given, and based on the data, you need to find the value of k and substitute the value of k in another set of two equations and to identify the nature of that equation. Okay, let's try to solve this. That is, let's form delta first. It is equal to 0, right? Delta is equal to 0. That is 1, 1, k, 2, 3, minus 1, 3, 4, 2. That is equal to 0, right? Is there any method to solve this other than expanding? I'm getting lazy to expand this, so I'm going to do the shortcut one. Okay. If you want to do this, either you can do along with me, or if you want some time, just hit the pause button and try to solve it by yourself. Okay. And what is the case here? What is the similarity? What is the property? Or how will you apply the elementary operation in this determinant to get the final output? Okay, let's go for this. Okay. 1, 2, 3, 1, 3, 4, k minus 1, 2, right? Easy. 1 plus 2 is what? 3. 1 plus 3 is what? 4. Therefore, k plus minus 1 should be equal to what? 2. That's it, right? That is 1 plus, see, if R1 changes to R1 plus R2, then the elements in the first row will be like this: 3, 4 and k minus 1. The last row is 3, 4 and 2. Both of them should be identical to get the final result is equal to 0. Okay, therefore k minus 1 is equal to 2. That is k is equal to what? 3. Okay, that is the value of k. See, if you substitute this also, you will get the value of k as 3. How? Because if you add these two, 2 plus 1, that is equal to 3, that is equal to k. Therefore, if you consider the constant term also, then also the value of k is 0. Okay. Since it is first degree, we don't have to bother about the other solutions. Okay, only one solution will be there since the power is 1. Okay, substitute the value of k here and you will get k plus 1x means 4x plus 6 minus 1, 5y is equal to 7. 7x plus 8y is equal to 10. It's over. Okay, the question is over. And you need to find the nature of these equations, right? How will you find the nature of these equations? It's very easy. Within one step, you will get the nature of these equations. Again, if you want to solve it by yourself, hit the pause button and try to solve it. Okay, very easy question. Okay, and how will you solve this? Very easy. This is, take it as equation number 1 and take it as equation number 2. Just go for this operation, 2 minus 1. And if you take 2 minus 1, what is 7x minus 4x? That is 3x. And what is 8y minus 5y? That is plus 3y. And what is 10 minus 7? That is 3. And it will be x plus y is equal to what? 1. Therefore, if you operate it, you will get an additional equation which should satisfy all the values of x and y, which you obtain from here. Okay, value of x and y. There will be a unique value for y and unique value for x. Okay, unique value for x and unique value for y. And this equation is derived from these two. Therefore, whatever the values which are assigning here for x and y, that the values also should satisfy here. Therefore, this one, unique solution satisfying x plus y is equal to 1. Okay, see, from these two equations, instead of solving the two equations, I have derived another equation. Okay, therefore practically there is 3 equations here. These 3 equations, if you use the concept of straight lines, these 3 lines are concurrent. That is, all of them meet at a single point. That is, that single point is the solution of all of these equations, and that single point is the solution of these 2 equations and this equation as well. Okay, and that is the concept which I have used here. Okay, very easy one. Next one. Okay, our very next question. See, this question has a specialty. To do this question, we need to know about geometric sequence and series. I can add 2 concepts of straight lines actually, and obviously determinants. Okay, the Cramer's rule. So, in this question, they have mentioned that for any 3 distinct consecutive terms of ABC of an AP, the lines AX plus BY plus C is equal to 0 be concurrent at the point P. Okay, and Q alpha beta be a point such that the system of equations x plus y plus z is equal to 6, 2x plus 5y plus alpha z is equal to beta, x plus 2y plus 3z is equal to 4 has infinitely many solutions. Okay, then you need to find the value of PQ square. That is the square of the distance between P and Q. To find Q, that's easy. You know how to do it. We have discussed a lot more questions based on that. Okay, we can use, I think, we can use a technique which we have used, using the properties of determinants. We can use this technique to solve, to find the value of alpha and beta. But what will you do for this one? 3 distinct consecutive terms of ABC of an AP, the lines AX plus BY plus C is equal to 0. Concurrent means 3 lines are concurrent means 3 of the lines are passing through a single point. Okay. So let's move to the next slide. So they have mentioned that A, B, C are in AP. Okay, they have mentioned that A, B, C are in AP. See, if 3 numbers are in AP, then we know that the double of the middle term is equal to the sum of extreme terms. That is 2B is equal to A plus C. And we know that the equation is given by Ax plus By plus C is equal to 0. And you know that it is a straight line equation. Okay, it's a first degree equation x and y. Therefore, it is an equation of a straight line. Okay. So, what we need to do from here is, what is B actually? B is equal to A plus C by 2. Okay, what is the value of B? A plus C by 2. Okay. So, substitute that value here and you will get Ax plus A plus C by 2 into y plus C is equal to 0. Okay. See, just arrange this equation in terms of A and C. Okay, that is 2Ax plus A plus C into y plus 2z is equal to 0. Okay. Just assemble the terms of A and C separately. That is 2Ax plus Ay plus Cy plus 2z is equal to 0. And if you took A outside, it will be A into 2x plus y plus C into y plus 2, which is equal to 0. And we know how to solve this. That is, since we know that each of the value of this equation is equal to 0, therefore each part should be equal to 0. That is y plus 2, which is equal to 0, and y is equal to minus 2. And here 2x plus y is equal to 0. If you substitute y is equal to minus 2, you will get x is equal to 1. Okay. So, the value of x and y for which the lines are concurrent is x is equal to 1 and what? Y is equal to minus 2. Okay. This question was asked before, okay, way before. Okay. Then they have assembled this question into this one. That's the only difference here. So we got the point P, x is equal to 1 and y is equal to minus 2. The rest is easy. Okay. Okay. We need to find the value of alpha beta such that the points x, y, z, these are infinity many solutions. Okay, let's try to solve it. Okay, 1, 1, 1, 2, 5 alpha, 1, 2, 3, which should be equal to 0, right? Okay, without expanding, could you tell me how to do this? Just using the properties of determinants, could you tell me how to do this question? Easy. What is 2 plus 1? 3. 1 into 3 is 3. What is 5 plus 1? 6. 2 into 3 is 6. Okay, therefore, if R1 changes to R1 plus R2, therefore it becomes 3, 6 alpha plus 1, 2, 5 alpha, 1, 2, 3. Okay, if you multiply this with 3, the corresponding elements in first row and third row will become equal. Okay, therefore 3 is equal to 3, 6 is equal to 6, therefore alpha plus 1 should be equal to 9, therefore alpha is equal to 8, and likewise we can go for beta also, that is 1, 2, 1, 1, 5, 2, 6, beta 4. Okay, that is if you add these two, it should be the double of this one. The value should be equal to 2 times this one. Therefore, 6 plus beta is equal to what? That is 6 beta 4, right? Okay, that is 6 plus beta is equal to 2 times this value. That is equal to 8. Therefore, beta is equal to what? 2. Therefore, what is alpha beta? Alpha beta is 8, 2. And what is point P? Point P, I think the value is, I forgot the value, 1, minus 2, right? That is 1, minus 2. Therefore, what is PQ square? That is 8 minus 1 the whole square plus 2 minus 2 the whole square. Okay, that is 7 square plus, I think the value is 49 plus 16, the value is 65. Okay, see, the benefit of doing this question is they have assembled the theory from all the 3 topics. Okay, but the theory is base level. Okay, see the benefit of doing mixed concept question is like this. If they arrange a question based on a single chapter or a single theory, they will try to make it more and more complex. Okay, not saying it will be hard, but if you try to do these types of questions, it will be very easy because it's the base level. It's just tip of all of those theories which is circulating here. That is ABC of an AP. We know that 2B is equal to A plus C. And concurrent line concept, which we have discussed so many questions based on that, you might be familiar with that, and infinitely many solutions that I don't have to tell that because so many questions we did this in this class already. Okay, I hope it's clear. Next one. Okay, let the system of equations minus x plus 2y minus 9z is equal to 7, minus x plus 3y plus 7z is equal to 9, minus 2x plus y plus 5z is equal to 8, and another equation is given. 4 equations are given. Has a unique solution, x is equal to alpha, y is equal to beta, z is equal to gamma. Then the distance of the point alpha, beta, gamma from the plane 2x minus 2y plus z is equal to lambda is. Here we need to use the distance formula. Okay, the plane might be deleted for you, but you need to keep focusing on the outline of that topic. Okay, some questions may be asked from the topic plane. Okay, from 3D. Initially it was there, now it got deleted. Okay, in 2023 also it was not for the board examination, but it was for the JEE and all. Okay. Okay. How will you do this? Easy actually. Minus x plus 2y minus 9z is equal to 9. Therefore, you need to solve the, see, the problem here is you need to find the value of x, y and z separately and substitute that value to obtain lambda, and then you need to obtain the distance formula for plane to find the final answer. So, how are you going to do it? Is it possible to use this equation? X is equal to delta 1 by delta, y is equal to delta 2 by delta, z is equal to delta 3 by delta. Obviously, you can use this equation to find the values of x, y and z, but it will consume more time, maybe more than 5 minutes it will take to solve that. So, instead of that, we are going to do the vintage method, that is the old method of solving this. See, if someone doesn't know Cramer's rule, there will be a method of solving this one, right? Okay, we are going to do that method to solve this, that is more easy. Okay, to find x, y and z, just go for this method which I'm going to mention right now. To find the nature of roots like infinite solutions, trivial, non-trivial, unique, inconsistent, consistent, for that you can use the Cramer's rule. Okay, to find the nature of the roots. To find roots, it's better to go with the method which I'm going to mention right now. Okay, so the method is like obtain x from here in terms of y and z and substitute that value here and here. Wait, what is x? That is, if you take this x to right hand side and this 7 to here, therefore it becomes x is equal to 2y minus 9z minus 7. Okay, that is what x is, 2y minus 9z minus 7. Substitute the values here and here. Therefore, what happens here is, if you observe closely, this value will become an equation in y and z, and this also becomes an equation y and z. If you have two equations and two unknowns, you can use the elimination method or cross multiplication method, any of the methods which you are studying in 10th standard to solve the question. Okay, so after substituting this here and here, you will get, okay, that is, here we have minus x, right? That is minus of 2y minus 9z minus 7 plus 3y plus 7z is equal to 9. Just open the bracket and you will get minus 2y plus 9z plus 7 plus 3y plus 7z is equal to 9. Okay. Therefore, this becomes minus y plus 3y is what? Y, and 9z plus 7z is what? Plus 16z, and 7, if you take it there, so what is 9 minus 7? 2. That is equal to 2. I think that's all. And for the second one, that is, here we have minus 2x, that is minus 2 into x is 2y minus 9z minus 7 plus y plus 5z is equal to 8. That is minus 4y plus, this becomes 18z plus 14 plus y plus 5z is equal to 8. So, minus 4y plus y, that is minus 3y minus 3y and 18z, 23z, right? Plus 23, sorry, plus 23z is equal to, what is 8 minus 14? That is minus 6. Okay, you do one thing, multiply here with 3. You know how to solve that, right? That is 3y plus 48 is equal to 6. See, just take it as equation 2 and this as equation 3. If you add the two equations, okay, if you add the two equations, you will get, I am writing it here, okay, since there is no space here. Minus 3y got cancelled, you will get an interesting answer. This is 671z, right? 71 is the DC equal to 0, that is z is equal to what? 0. That's it, done. What is the value of z? 0. Okay, if z is equal to 0, and what is the value of y? Just substitute it here, you will get the value of y as what? Y is equal to 2. Okay, now we got z and y. Then, what is the value of x? X is equal to 2y minus 9z minus 7. Substitute it there, you will get x is equal to 2 into 2 minus 0 minus 7. Therefore, what is the value of x? X is equal to minus 3. So, basically the values of x, y and z are minus 3, 2, 0. Okay, so substituting the value of x, y and z in this equation, you will get x is what? Minus 3. Therefore, in here you will get minus 3 into minus 3 plus y is 2, right? That is 2 plus 30 into 0, which is equal to lambda. Therefore, the value of lambda is what? 9 plus 2, that is 11. The value of lambda is 11. So, you got all the three values and you need to substitute this formula to get the distance from the plane. Okay, the formula I will write it for you. I hope you know you are not familiar with that formula. See, the equation of a plane will be like ax plus by plus cz plus d is equal to 0. Let's consider a point x1, y1, z1. The distance from this point, the shortest distance from this point to this plane, let's take it as p. See, this formula is, the structure of it is similar to the formula of which we use in straight lines. Hope you remember that formula. Shortest distance from a point P, x1, y1 to a straight line ax plus by plus c is equal to 0. Okay, what we are doing here, the exactly same thing, you have to do it here to get the final answer. Okay, so just substitute P here, you will get P is equal to ax1 plus by1 plus cz1 plus d, the modulus divided by root of a square plus b square plus c square. Got it? Okay, therefore this formula is what we are going to use here. Okay, let me take the values first. X is minus 320, right? That is minus 320 is the value, and lambda is what? 11. Now let's take the equation of the plane, which is 2x minus 2y plus z is equal to lambda. 2x minus 2y plus z is equal to lambda. Let me check that once more. 2x minus 2y plus z is equal to lambda. Okay, substitute this point here. Okay, if you want, just write like this, minus lambda is equal to 0. Okay, minus lambda is equal to 0. Let's substitute the value here. You will get 2 into minus 3 minus 2 into 2 plus 0 minus lambda. And what is the value of lambda? 11. Just substitute that value, and here you will have 2 square plus minus 2 square plus 1 square, the respective coefficients. That is, this is minus 6, minus 4, that is minus 10, minus 21, that is 21, 21 divided by 3, that is equal to 7. 7 is the shortest distance from that point to the plane. Okay, that's all. Okay, so if you know the basics of all of the topics, it's very easy. Okay, next one. Told you, possibly they will assemble or integrate how many topics they can over here. Okay, here they have assembled a question from probability and determinants. Okay, it's a very easy question, but if a student doesn't know probability, he might not be able to answer the question. Okay, and if a student know well enough probability and does not know the basics of determinants like the Cramer's rule like that, he might not be able to attend this one. But if a student know the basics of Cramer's rule and probability, this plus 1 level probability only, he will be able to crack the question. Okay, see, they have assembled questions from sequence and series and determinants, integration determinants, differentiation determinants, like that. Okay, you can expect that much from this year. Okay, so what we are going to do is, see, let n denote the number that turns up when a fair die is rolled. That is, n can be 1, 2, 3, 4, 5, 6. It's a very easy question. Okay, very easy question. And if the probability that the system of equations, the three equations are given, okay, x plus y plus z is equal to 1, 2x plus ny plus 2z is equal to 2, 3x plus 3y plus nz is equal to 3, such that it is having a unique solution. The probability that this is having a unique solution, okay, is k by 6. Then the sum of values of k such that and all possible values of n. Then the sum of value of k and all possible values of n. Okay, let's try to do that. See, for this system of equations to have a unique solution, then its determinant cannot be equal to 0. That is the only condition. Okay, let's assemble it then. That is 1, 1, 1, 2, n, 2, 3, 3, n. Okay, which is not equal to 0. Let's equate it like this. See, it is the most easiest determinant which we have faced and which we are going to solve today. Could you tell me the values of n? There will be two values, because we know that if you open the determinant, there will be an n square term here, and if we equate that n square, you will get two values for n. Okay, but for that there is no need of opening the determinant, but you should have an idea that the power of n will be 2. Okay, so what will you do here, or what are you going to do here to find the values of n? It's a very easy question. See, listen, if n is equal to 2 here, then this row, the elements in this row become a scalar multiple of this one, right? That is, if you multiply 1, 1, 1 with 2, you will get 2, 2, 2. Or you can use this one. If n is equal to 2, 1, 2, 3, 1, 2, 3. This and this becomes same, right? Could you tell me another value of n? Very easy one. One more value is there actually, that is n is equal to 3. There is two values, n is equal, for n not equal to 2. If n is equal to 2, then this becomes 0. There is one more value which is 3. That is, if n is equal to 3, then this becomes 0. Therefore, n cannot be equal to 3. That is, n not equal to 3. That is, if n is equal to 3, then first column and third column will be same. I hope it's clear. Therefore, two values of n cannot take the two values. Okay, so from this 6 values, n cannot take 2 and 3. I hope it's clear. Okay. So n can take the values 1, 4, 5, 6. So what is the probability of getting any of those 4 values? See, only if n took 1, 4, 5, 6 the values, one among the 4 values, only then the system becomes a unique solution. System of equations will have a unique solution. Okay, so to have any one among the 4 values, the corresponding probability will be 4 by 6. So equating that, what is k? K is equal to 4. Okay, but they have asked you to find the sum of value of k and all possible values of n. Therefore, you just need to add this 1 plus 4 plus 5 plus 6 along with that the value of k, that is 4. That is 4 plus 1 plus 4 plus 5 plus 6. What is the value? 5, 10, 14, 20. 20 is the correct answer. Okay, that's all. I hope you got the idea here. Okay, these are some of the important questions which we have discussed right now. Okay, so just go through that questions once more and try to do the questions by yourself. Okay, just go for the key if you want. And I hope you understood some of the concepts which we have discussed here. Okay, and just do some more questions and do more and more problems. Only then you will get a proper idea of this topic. Okay, we have laid the foundation here. Okay, so that's all for today. We have discussed some of the important questions from determinants based on Cramer's rule. Okay, I hope you understood all of that. And do one thing, that just go through these questions once more and do it by yourself. Okay, just go for the keys only, okay, without looking at the solutions, and do more and more questions, only then you will get a proper idea of this topic. Okay, we have laid the foundation for now. Okay, and once again, thank you all for listening and see you in the next video.